Hello, this is Mr. Huber. In this lesson, we're going to look at solving absolute value inequalities. If you recall, an absolute value means the distance a number is away from zero. So now we want to talk about absolute value inequalities. Here we can see the absolute value of x is less than 3. That means the distance from 0 is not equal to 3, is something less than 3. So it means the distance is between 0 and 3. If we have the absolute value of x is greater than 3, that means the distance from that number and 3 is greater than 3. Distance that number and 0 is greater than 3. So we want to look at greater than 3 means the distance is further away from 0 than 3 units. Less than 3 means it's closer than 3 units away from 0. So what does that look like on a graph? We can see down here below. The graph of absolute value of x is less than 3 means the number is between -3 and 3. That distance here is closer to 0 than 3 units away. Or if it's greater than 3 units, it means it's more than 3 or less than -3. And we can see that down with our compound inequalities at the bottom there. Okay, on this side here, we have x is between -3 and 3, right? It's greater than -3. It's less than 3. Greater than -3, less than 3. That's one of those and compound inequalities. Over here, an or compound inequality means it's less than -3 or greater than 3. Okay? When we solve an absolute value inequality, we want to isolate the absolute value expression first. We've seen that with the equations as well with absolute values. Get that absolute value part of the inequality by itself, and then we can go from there. When we're setting up our compound inequality, because every absolute value inequality is going to end up being a compound inequality, okay, we can set it up as a greater than or a less than. So on this side over here, greater, think of as greater. Greater. When you have a greater or greater than or equal sign, we're going to set up an or compound inequality. When we have a less than or equal to, think less than. We're going to set up an and compound inequality. So a greater, less than. So we're set up an or an and compound inequality. Let's see what those look like. So this first one, absolute value of 4x minus 6 is greater than or equal to 10. Greater. So again, this symbol right here means we're going to set up an or compound inequality. How are we going to do that? Well, like we did with equations where we set up equals 10 and -10, similar to that, now we're going to have absolute value of 4x minus 6 is greater than or equal to 10, and then we're going to have absolute value of 4x minus 6 is less than or equal to -10. So that's our two inequalities, and it's going to be or. Okay. So now we can solve these. Okay. We don't need those absolute value bars there. We take those right out. Okay. And we're going to be able to add 6 to both sides and get 4x is greater than or equal to 16. Add 6 on both sides of this one. If you want, sometimes it can be good to solve them at the same time because you're going to basically be doing the same steps. Or you can solve them each individually. I'll do them both ways, and you can get comfortable with what way works best for you. And we'll have x is greater than or equal to 4. X is less than or equal to -1. Or. Again, or it can't be both of those. There's be possible to have a number that's greater than or equal to 4 and less than or equal to -1. Okay? And if we draw that out on a number line, because we want to graph our solution, okay, we have 0, -1, 1, 2, 3, 4. And at 4, we're going to have a dot because it's greater than or equal to 4. And at -1, also a dot, less than or equal to -1. Okay, one or the other. Again, those compound inequalities, or we'll have graphs going opposite directions from each other, a little gap in between. If we look at number 2 here, absolute value of 2x plus 2 minus 5 less than 15. The first thing we want to do on this is get the absolute value by itself. So if we add 5 to both sides, we'll have absolute value of 2x plus 2 is less than 20. So we can set up our two inequalities now. We're going to have 2x plus 2 less than 20, 2x plus 2 greater than negative 20. And when I go to solve these, I'm going to subtract 2 on both sides. Get 2x is less than 18. Subtract 2 on both sides here. 2x is greater than negative 22. And now, if I divide both sides by 2, if x is less than 9, divide both sides by 2, so we should add an x there. And we'll have x is greater than negative 11. So we can see from our two inequalities here, right, that we have an and situation. We can write and in between here. And if I want to graph this, I would have, say that's 0, and there's 9, there's negative 11, and less than 9, open circle, greater than negative 11, open circle. So less than 9 going this way, greater than negative 11 be going this way. It's in between those 2 points, right? Because if we overlapped them, we would have less than 9 going like this, greater than negative 11 going like this. So we want the part of the graph where they overlap, right? So we'd be looking for this part of the graph right in there, okay? Right between those 2 points. And again, you can write it out as an and then graph it like an and, where we have the 2 points and then they overlap in between. Again, you can check these, take numbers that are parts of your graphs of your solutions, plug them back into the original inequalities, make sure that they work. Right. A little time for a capital conundrum. Conundrum, maybe something difficult to figure out that's puzzling. What are the only 2 state capitals that have the name of the state in the name of the capital city as well? So it'd be like Lansing is the capital of Michigan. The name Lansing doesn't have the word Michigan in it. So the name of the capital has the name of the state in that capital city name. There are only 2. Oklahoma City, Oklahoma, and Indianapolis, Indiana. So a little interesting fact about those couple state capitals. All right, let's try 2 more absolute value inequalities and solve them. This first one, again, we have to simplify, get the absolute value expression by itself. So if we add 12 to both sides, we'll have 3 absolute value of 5m minus 13 less than or equal to 9 plus 12 is 21. And then if I divide both sides by 3, I get absolute value of 5m minus 13 less than or equal to 7. And now I can set up my 2 inequalities. I have 5m minus 13 less than or equal to 7, 5m minus 13 greater than or equal to negative 7. And if we look up at the beginning too, we saw it was a less than. We should be getting an and. That's something just to keep in mind as we go through this. And if I go to solve these now, I can add 13 to both sides and get 5m less than or equal to 20. Add 13 to both sides here. 5m greater than or equal to 6. And when I divide both sides by 5 on both of these, I'll get m less than or equal to 4. And then I'll get a fraction here. That's fine. We can leave it as a fraction. M greater than or equal to 6 over 5. That's and. Keep in mind, when I go to write that out as well, I could write it as 6 over 5, and less than or equal to m, less than or equal to 4. That's another way to write out that and compound inequality. Again, we saw up here the less than. Less than means we set up an and. We should have an and at the end. And when I go to graph it, right, that and compound inequality is going to mean that at 6/5, which is a little bit more than 1, 2, 3, 4. So 6/5 is, maybe right in there. And then 4, and I have dots for both of those because they've got the equal to, and then everything in between them. Okay, this point right here would be my 6/5. little bit more than 1. Let's check out number 4 and solve that one. So I'm going to divide both sides by 2 here first. I have absolute value of n plus 8 less than negative 8. And that's going to give me n plus 8 less than negative 8, n plus 8 greater than positive 8. And if I go to solve these now from here, I get n is less than negative 16, and I get n is greater than 0. Okay, we saw less than. Again, this should be an and compound inequality. So and. So this is telling me I should have a number that's less than negative 16 and greater than 0. That would be impossible. I don't think we're going to find a number that is less than negative 16. Pick any number less than 16. It's not going to be greater than 0. Or pick a number greater than 0, like 5. 5 is not going to be less than negative 16. So this doesn't work. So what may have happened? Again, in any of these, we'd see, does it make sense? We could pick like 1 and plug it back in up here to my original inequality, make sure they work. You're not going to be able to find a number that satisfies both of these inequalities. That'd be impossible. Here's why. In this step right here, we had the absolute value less than a negative. That means this absolute value would have to be equal to a number that's less than negative 8. Absolute value can't be less than 0. Okay, an absolute value cannot be less than 0. So it can't be less than negative 8, because it'll never be a negative number. So watch for that, keep that in mind, and this would be one of those where we'd have no solution. So no solution. When you get the absolute value isolated by itself, this is the point where you want to look and see, do I have a negative? If this was negative, but maybe this was negative 2, and I divide both sides by negative, it comes out positive over here. So you want to be careful. Or if this was a negative 9, but when I added 12, it came out and it was positive then, we could still solve it. So when you get the absolute value by itself, make sure it's not less than a negative. Right? So make sure that you're practicing solving and graphing those and looking for those times where you're going to get solutions that don't work.